This is part 2 of the Unit 5 lab. And so what we're going to do now, we melted the ice. It's at 0 degrees. There is still some ice remaining. We are going to find the mass of the calorimeter with the cover on and the ice remaining after 0 degrees. But we're going to dump out all the liquid water. Maybe. There you go. Oh wait, no, sorry, did that wrong. All right, so let's dump out all the extra water into the sink. So now inside, I still have the ice that did not have a chance to melt. And so what would the mass of the remaining ice and the calorimeter be? It would be 441 what? Grams. And now we got to do a little bit of figuring. So the next thing says mass of water after temperature was 0 degrees. So in other words, how much water did we dump out? So here was all of the calorimeter and the ice and the water. Here is the calorimeter and the ice, and so just subtract those numbers. And what do you get? $61 what? What would the unit be for this? It would be grams. So that's how many grams of water we had. And now we have to find the heat, because that was the whole object of this lab, was how much heat energy did it actually take to lower the temperature of the water down to the temperature of the ice, and at the same time, some of the ice was melting. So find the heat, must show work. Q equals mc delta T. So our mass is right here. That's our mass. And we're going to multiply it by the specific heat of water, and that's a given value. That's always the same for pure water. And we're going to multiply it by the change in temperature. All right, so we went from 22 degrees Celsius to 0 degrees Celsius. So what would our change in temperature be? Oh, we went from 22 to 0, so 22 degrees. All right, so we're going to multiply these numbers together. So we're going to multiply 61 times 4.18 times 22, and that's going to tell us how much heat we had, equals Q, which needs to be lowercase, and that's the amount of heat. So put it in your calculator. What do you get? I have 61 times 4.18 times 22, and I get 5,609.56 what? What would my unit be? This is for heat. Well, is it grams, joules, or degrees Celsius? Which one tells us heat? Grams tells us what? Joules tells us what? Degrees Celsius tells us what? Heat is measured in joules. Grams is for mass, and degrees Celsius is temperature. All right, so now I want to know how much of the ice melted. I started out with 47 grams of water, and that increased up to 61 grams of water. So we had a change in water, and of course, where did that water come from? It came from the ice. So if I want to know how much ice melted, I'm just going to subtract those two numbers. So 61 minus 47 equals 14. 14 what? 14 grams. All right, so it took this much energy to melt this many grams of ice. And so now we can figure out how much it took to melt each gram, or in other words, the enthalpy of fusion. So go ahead and put that in your calculator. And we have 5909.56 divided by 14. That means every single gram took 422.11 joules of energy to melt each gram. Okay? Now, had this lab been perfect, Our answer right here should have been 334, but it wasn't. It was 422.11. So we need to figure out how close to the actual answer we were. And to do that, we put it in this equation. We say, what did we get minus what should have we got? And we put it with these bars around it instead of a parentheses. So not a parentheses, but a bar. And those bars mean absolute value. And that means that your answer has to be positive. All right, and so we're going to subtract those two numbers, and then we're going to divide it by what we should have gotten. So go ahead and put that in your calculator. Oops, let's try again. 422.11 minus 334, and then I'm going to divide it by 334, and I get 0.26. And then I want to times it by 100 to change it into a percent. So if we times it by 100, what percent do we get? 26%. So we had a 26% error. So not the worst in lab. All right, so let's talk a little bit more about the lab. Where does the heat come from to melt the ice? Came from the water, because the water was warmer, and heat always goes from hot to cold. Define enthalpy of fusion. So that was the amount of heat needed to change from a what to a what. Do you remember? What did we do in this lab? Did we make ice or did we melt ice? Okay, so we melted ice, so it's from a solid to a liquid. And we have a few questions about phase changes. So let's go up here and I'll just go ahead and ask them. So when we look at our phase changes, during a phase change, how many phases are present? So phases are solid, liquid, and gas. And when you have an actual phase change happening, how many phases are present? 2. When it's melting, you have the solid and the liquid. When it's vaporizing or boiling, you have the liquid and the gas. Heat can do one of two things at a time. What can heat do? Heat can change the temperature, or it can cause a phase change. And during a phase change, how would you describe the temperature? The temperature is constant, or the temperature does not change during a phase change. And so we said heat can do one of two things. It can either change the temperature, or it can cause a phase change. What is heat specifically doing during a phase change? It's actually ripping the molecules apart from the other molecules. So it's changing or breaking the intermolecular force. So inter meaning between, like an interstate highway, like Interstate 94, between states. Well, these are forces between molecules. So we have two H2O molecules next to each other, and the heat says, nope, spread apart, you're too close. And when it boils, the heat says, nope, spread apart even more, you're way too close. Time to become steam. So heat can only do one thing at a time. It can either raise the temperature, which causes the molecules to move faster, or it can break them apart from each other so that, again, they can change the temperature and they can start to move faster. All right, go ahead and email me, Mrs. KJ, that you're done with the lab so I can check it over. As always, if you have questions, please let me know.